so that we can start. So once again, good morning everyone. This will be our last topic for the third quarter, lasers. So to start, let's have our first trivia. Laser is an acronym which stands for. Yes, group 2, Rexy.
Light amplification by stimulated emission or radiations.
Radiation, very good. So laser stands for light amplification by stimulated emission of radiation. So, nilagay. Update tong score. Group 2, 1 point. So, nga gitawag siya nga laser, it's because of this na meaning. Light amplification by stimulated emission or radiation. So, basically, inang laser is just stimulated emission of light. So, later on, we will find out why was it called that way. So what is a laser? A device that produces a coherent beam of optical radiation by stimulating electronic, ionic, or molecular transitions to higher energy levels. When you were in grade 9, this will remember about ng excitement of atoms, especially electrons. Sino kadumdum? What happens when an electron is excited? Anyone? You can raise your hand. This was discussed when you were in grade 9. Then sino ito nag-raise hand? Yes, Lorraine.
Ga, release sa energy, sir.
Ano, Lorraine?
The release energy.
Ga-release energy, okay? But before that, mano danay? Before siya mag-release energy, mano danay ang electrons? Di ba? It's true, correct, na at some point, it will release energy when it will be excited. Di ba, to be excited, it must have a spectrum absorption, may absorption sa danay. Then, this electron will get excited. And when it gets excited, it will, ano matabo sa electron? It will, anyone? Naman niyo pa? Di ba mo nang explain nga sa isari ang colors, ang mga elements, each element have their own ng spectrum of colors or fingerprint nila, nga ang fireworks sa isari color. It's because, sige it's because electrons, they jump to a higher energy level. Correct? So, pag absorb nila yung energy, this electron will jump to the next energy level depending on the amount of energy it has absorbed. Then after a quick amount of time, it will go back to its original energy level, thus emitting light or another energy in the form of photons, and that's what we see as light. Okay? So, laser is coherent, meaning it is only ng one direction, concentrated, hindi siya scattered. Di ba when we discussed interference last meeting, na we were able to tackle a coherent ng source of light. So kung nung laser, that's coherent. Pero yung mga fluorescent, that's non-coherent, kay scattered ang yung mga light. If you've noticed, usually ang portrayal sa mga lasers, they are ng concentrated, single direction, ng one directional. Correct? So makitaan mo gid ang beam because it's coherent. So of course, from the three main processes, absorption, emission, and stimulated emission. So we will be tackling each of this process later on. So yeah, next trivia, it is said to be the predecessor of the laser. What is this? Okay, what is the predecessor of the laser? Yes, Jaya, group 1.
Maser,
Okay, that is
sir.
the maser. What does maser stands for?
Microwave amplification by stimulated emission of
Okay,
radiation.
so this one, it is maser or microwave. So microwave yan ang ginagamit sa aton nga maser. So group 1, tie at 1 point each. So let's have some important names to remember. So Charles Hart Towns and Arthur Leonard Shawlow invented the laser. But it was si George H. Mayman who built the first laser in 1960s. Amo siyang yung famous na nga ruby laser. Amo siyang red nga laser na ginagamitan siyang rubies. Okay? So Charles Hart Towns and Arthur Leonard Shawlow and Theodore H. Mayman. So properties of laser, number 1, they are monochromatic. Usually they are just being fired with one color. So on red, red lang. Wala sabo-sabo nga colors. They are coherent, so all the emitted photons bear a constant phase relationship. So we discussed phase relationship last meeting, sa interference, with each other in both time and phase. And of course, they are directional. They're focused on one direction because they're strong and concentrated. That's why ang mga laser nang they generate ng intense amount of heat, usually ng init na siya mga laser, especially sa mga mga eye surgery, mga cutting beam ng mga laser, pang-cut metals, pang-cut diamonds, di ba? So lasers ang ginagamit because it is very very intense. What makes it intense is because of its directional or one direction concentrated nga pag-fire sa katong nga laser. Okay? Question so far? Questions? None. Okay, let's proceed. So, muna siya absorption, emission, and stimulated emission. So, to introduce this concept, apat ang bako gina, kung mag-fire ka the energy or light sa or heat sa imong electron, absorption, it will absorb the energy. Then this electron will jump. Okay? Pag jump yan, hindi siya magstay forever sa next energy level or sa higher energy level. It will go down in a short amount of time, emitting another photon. That is continuous emission. So stimulated emission because this emitted photon will again hit another electron, creating a chain reaction. And that is nang generating your laser. So energy is absorbed by an atom. The electrons are excited into the vacant energy shells. So, muna siya ang E1, energy level 1, energy level 2. So, kung may ma-hit ng electron, they will jump to the next energy level. But, this electron will not stay there forever, so it will go down. Then, as it goes down to the original energy level, it will emit another photon to the energy HB. So, kanano yung ginabsorb, ang mamana ang iyang i-emit. It is a completely random process. Then, ang gitawag na stimulated emission is atoms in an upper energy level can be triggered or stimulated in phase by an incoming photon of a specific energy. So, di ba ang imong electron nag-emit na ni photon? Ang na-emit nga photon, ma-hit naman another electron of another atom. Then it will release naman another photon. At the same time, ma-release mo siya another photon. Then it will create a chain reaction. So, kung ang laser mo is concentrated, it will be, ang atong final result will be a monochromatic, one direction, and concentrated nga beam. Okay? So, that is the concept of lasers. Absorption, spontaneous emission, and stimulated emission. Question so far? Questions? None. Alright. So, stimulated emission have unique properties in phase to the incident photon, same wavelength, and same direction. So, muna siyang stimulated emission in phase, same direction, and same wavelength, of course, because it is in phase. So, di ba kung in phase siya, it will also have the same wavelength as the incident photon. So, kung ang imo ng incident photon, it will have the same direction and same wavelength. Okay? and they travel in the same direction. Next trivia. What do you call these crystals that are rare force-attuned crystals that grow in nature that are used in making lightsabers? What is the name of this crystal? Okay, Star Wars people. Yes, Rexy.
Fiber crystal, sir.
Ano na?
Fiber
Correct.
crystal.
These are the Kyber crystals. Galan to, ni si Rexy Star Wars mo. Or, may lang or na lang So these are your Kyber crystals. So actually, of course, George Lucas, ng basis lightsaber sa concept ng isang laser. Okay? Because as what I've said, the earliest form of lasers make use of the ruby crystals. Ito bang mention ko gina, kahit Tudor Mayman. So, ang ruby crystals, kinabutan sa tsaka chamber. So, kung mo ni mga focusing crystal. So, gina-fire nila siya energy. This will be your energy source. Amo na yung mga energy source, ang may blade energy channel. So, mag-fire sa energy, and this crystal will emit that energy nga magwa di in the form of your laser. So, amo na siya makita nga laser. But of course, it is not possible for the laser to only reach at a certain point. So, nag-extend na siya. But right now, may mara na mga experiment that they actually form a laser that is super hot. Gida nga, do ka laser, lightsaber, I mean. So far, dumi mo na siyang experiment nila na form. Okay? But anyway, in fictional terms, that is called as a Kyber crystal. The equivalent of our ruby crystal. Okay? Ano pa kita? The clone troopers were generic clones of which bounty hunter? Sino ni sa? Di nagalin ang aton nga mga clone troopers. Di ba there are three types of troopers? The stormtrooper, the death trooper, and the clone troopers. Kung ganito ka mo Star Wars. Okay? Di engine base ang aton nga clone troopers. Yes, group 2.
Sir, good morning.
Ano
Kay
na?
Django Fit, sir.
Yan na?
Django Fit,
Django Fett, okay? Spell Fett.
F-E-T-T, sir.
Okay, Django Fett. It's not Django Fett. That's
Ay,
Django
Fett, sorry,
Fett.
sir.
So, muna siya I think, ang bata ni Boba Fett, ang sa early nga Star Wars. So, muna siya naging base, sorry, gali. So, naging base ang atong nga clone troopers. So, Star Wars, kita niyo nang may error, may nakabunggo nga trooper nadala sa film. Buhay nila nakat, nabunggo sa ato. Okay? So, muna siya kung ganito ka mo Star Wars. So, group 2 got another point. So, group 2, 3, group 1, 1. Okay? So, as a summary, absorption, it will absorb, this electron will absorb, it will jump to the next energy level. Then, it will go down, emitting another photon. And this photon will hit another electron nga mag-jump naman and mag-go down, and then they will have a chain reaction. That is what is happening inside your chamber or ang aton nga optical confinement layer. So as a concept, ang aton nga laser, mayroon siya tawag nga chamber. That is, one is a reflecting mirror and the other is a partially reflecting mirror. So ang sulod sina sa aton nga chamber, actually the electrons that gets excited and that gets itself to emit ng photons. So didiligaw ko na itong chain reaction. So remaining power reflects through cavity for amplification of certain wavelengths. A process known as optical feedback. So construction is very similar to the LEDs. Di ba ang LED, mga example, mga isang coherent na light. That's why ang LED, do ka dot gid ang light, do ka concentrated nga dot. Ang sa mga laser na lagi nabakal nyo sa jelly, umusang do mga LED, do ka almost laser like ang ilang pag-fire sa aton nga light. So this is a reflecting mirror. So basically may mga mirror na diyo that helps in the spontaneous emission of mga photons. Then pagwa, amo na siya ang atong tawag nga laser. Okay? But not all lasers are of course dangerous. Most nga lasers walang susat ng ulo ng laser gun. Okay? Di ba we have medical lasers? Ang na-mention ko gina mo tong sa sa mata, mag-correct sa mata, and even lasers are being used to burn, mag-CD burn bala. Anyone may idea, ang itawag na nga CD burn? Ang itawag na nga ma-burn ta CD? What's the reason behind? May logic na da. Nga agi tawag na siya nga CD burn, CD burning. Sa trivia ni siya ano sa di ba last meeting na trivia ko sa meaning ka DVD. So actually dapat na i-discuss nga gitawag siya nga CD burning. Sige ba? Kung gapa-burn ka mo CD, gapa-burn, gapa-butang ka mo music or files sa CD, nga ang tawag na siya nga burn. I don't know kung uso pang CD or DVD sa inyo. Walang kabalo. Gagamit pa ka mo CD, DVD. Duga stream naman lang ka mo download sa internet, no? Sige ah. Anyone? Why was it called CD burning? Okay? Wala idea. So, ito siyang CD burning because ang CD gina literally burn. Okay? Using laser. O, nilagay MJ. Sige be. Can you elaborate? Dayaw.
Because, sir, a laser in the CD uses heat to record the data to the disk.
Okay, so gina-record na siya ang data. Pero para siya maging-record, gina-firean sa laser. So ang imo na nga laser beam, it literally burns the CD, the surface of the CD. So that's why ang CD na actually, may mga gagmay na siyang mga grooves, mga buho-buho, balaklas. So amo na siya ang ginabasa naman sa imong nga CD player, ang grooves. So basically, well, hindi na makita, ginakortihan na siya, ginasunog sa CD burner nga para mabasa sa CD player. Okay, so muna na siya ang simple nga explanation. So let's move on. So muna siya ang 100% reflective mirror, then partially reflecting mirror to ensure that bounce back lang na din atong emission until may time nga too concentrated and they will be fired in a na monochromatic or one directional nga manner. Okay? So, muna gyapon na mirrored surface, partially mirrored. So, pag-fire sa aton nga energy from this point, mabunggo-bunggo na diyo, masigisigin diyo bunggo until such a time that it can now release a laser. Okay? So, pumping the laser sa absorption. So, ma-excite. Then, pagka-excite, ma-excite manaog, ma-release sa mga photons. Then, among yung mga yellow, mga photons, may go naman other atoms. So, ma-chain reaction lang until ang aton nga mga photons will be fired in one direction. So, the same frequency, the same phase, and the same direction. Siyempre, the same frequency because they have the same wavelength. So, they will be fired in one direction. So, una, naging incoherent, then naging coherent ang aton nga light. Di ba incoherent, saka nag-bounce back lang siya until maging coherent na siya. Okay, so what are the applications of laser? There are many applications. Scientific, you have the spectroscopy, ng laser cooling, nuclear fusion, so on and so forth. Then for military, mga death ray, mga railgun, very powerful weapons. Kaya nga, compared sa mga missile, wala na siya ng pollution. Wala siya pollution or chemicals. Kaya nga, it is only pure light. So pagkaigo, amo lang gina siya. Boom. Defensive application, so missiles, they make use of laser. That's why mga rangefinder, mga missile, black class nga ito kahit seeking na lang, they make use of laser. They can hit a target no matter where they go. Of course, ng laser sight, or ginagamit man sa buong laser sa mga defense. I think you're familiar naman guro what is happening to ng Israel. Di ba so may gira sila. And one defense system being used there is the Iron Dome. Familiar ka muna. Ang Iron Dome, among isang duga intercept sa mga incoming nga missiles. So before mag-hit ang missile sa ilang city, galupok na sa langit, sa sky, kaya gina-intercept na ang ilang missile. So they also make use of lasers. So ng laser sight, ang mata mga pusil, kung pa mo Call of Duty, ng dako-dako ginambuli ka mga laser sight to increase accuracy. So and so on and so forth. Laser tags were inspired by the phaser guns of what famous film? So wala pa ko pang laser tag. Ang pinaka-closest nga ako nga tirohay ng bangko is tirohay pellet gun. So sang gamay kami tirohay kami pellet gun drohay. So laser tags, ano siya nga famous sci-fi film game base? Okay? Go. Di lang kita nalipat ko kayo, sir. Close ko danay. Ching. Ay lang na-close it. Di lang ka siya. Sige, you can answer. Well, I'm opening it again. Yes, group 1.
Star Trek, sir.
Correct. The answer is Star Trek. So, I'll just present the ano na liwat. So, mas una actually ang Star Trek, I think, compared sa Star Wars ng window. Okay, can you see the presentation? Kita ko na class? Okay, ng class, can you see the presentation again?
Yes, sir.
Okay,
Yes,
very
sir.
good. So Star Trek, that is the basis of the laser tag. So kung laser tag, I think you know naman the concept. So laser tag have receptors that again make use of lasers. May mga chips na sa. So dapat ang laser nga i-fire, it must hit this particular target areas that will generate like vibrations or mga sound to indicate nga may guan ang target or nga patay na ang target. Okay? So, namin siyang experience. Sa mga gusto ko man may experience ang laser tag. Pero namin, kitiga po, tiro kay pellet gun. Kay ma-feel mo, ganyan mo. Yan. So, playlasertags.com. So, may video na siya actually. So, galing kayo ng new laptop kung siya ma-play. But you can just watch ng laser tag presentations or video sa YouTube. Of course, ng lasers are not just used for destruction, but for medical purposes. Like your eye surgery and cosmetic surgery, ginagamitan na sa laser to correct mga cataracts, mga damages sa eye. So kung ganun to, kung wala final destination, di ba sa final destination, may scene na nga gina-laser yung nga mata. Galing dapat ang laser, it must be ng controlled. So may limit na siya sa heat nga dapat nga i-emit kahit sobrang nga heat. Remember, laser is very concentrated. It can actually damage your eyes. So, pwede ka mapaso and even worse, pwede masunog kung wala na control ang energy nga gina-fire or gina-emit sang laser. Okay? And of course, industry, cutting, welding, your CD player, your laser printers, mga laser light display, mga holograms, mga disco lights, laser pointers, they all make use of lasers. Although, mga weak na sila yung lasers. Okay, usually. Unless, of course, sa mga cutting, welding, marking, ano na niya mga intense na ganyan mga lasers. Make use sa industry and commercial purposes. Okay? So, lasers are generally classified according to their energy or safety. So, class 1, naman sa mga safe lang ang mga lasers. They don't do much damage unless you expose yourself at a very, very long time. So, does it mean nga green na presentation laser, be yellow, nga safe siya, doesn't mean nga pwede mo na matuon sa imong mata for 1 hour. Correct? Ang laser. So, ibansin nyo, be barcode reader, naga-shopping kamo sa City Mall, kita mo barcode reader, so ga-squat kamo gina barcode nyo inyong itsura para mabalaan nyo inyong halaga. So, some measuring and targeting device. Then, of course, ang very dangerous, ang medical lasers. Kaya muna siyang mga init na gid, mga cutting, kaya pwede gid man, no? Usually, lasers are used for cutting diamonds. Laser ang ginagamit. And we all know that diamonds are the strongest or the hardest material so far. Then of course, laser light show equipment. So just very careful to not really expose yourself sa lasers at a very, very long time because they are still concentrated forms of energy. Question so far? By the way, I'll be giving a short quiz lang yapon. It will be na written sa Google form na i-upload ko lang later after ko mag-klase sa Curie. Kaya ma-upload ang mga videos para dululungan ta. Okay? So, question so far? None? Sige. So, right now, I'll be presenting you a video, a last video on how lasers work. You can see this video on YouTube, man. But, for now, I'll be presenting it to you. Okay? Can you hear the audio? Okay. So Einstein was a major contributor of the laser.
The stimulated emission of light was a discovery by Einstein around 1916. All we need is an atom which possesses electrons just like any other atom in our world and a photon, that is, a quantum of light. The atom has electrons orbiting the atom's nucleus. For a better understanding, the Bohr model of the hydrogen atom will be used. The hydrogen atom has only one electron. The atom and the electron are on the ground state, namely E0. However, an electron may have other discrete values of energy. For this example, two energy levels will suffice, E1 and E2. An electron can be excited to a higher energy level by absorbing a photon whose energy is equal to the energy difference between the levels. The electron is said to be excited. However, after a very short time, the excited electron will go to the lower energy level by emitting a photon equal to the energy difference.
Okay, so very, very short time lang ida. Pagka saka, manawag sa dayang balik, that will emit a photon equal to the one it
This is
received.
called spontaneous emission. But when an atom absorbs a photon, and after a short time another photon is absorbed, a stimulated emission will be the result. The newly created photon has the same phase, frequency, polarization, and direction as the second photon. So it's a copy. The operation of lasers is based on the process of stimulated emission. Here we will discuss a three-energy level design. A photon is absorbed by the atom. The photon has enough energy to lift the electron from energy level E0 to energy level E2. Shortly afterwards, the electron jumps into energy level E1. This can occur without emission of a photon. A laser device is made up of several components. First of all, a mirror with a reflectivity of 100% is installed at one end of the device. Furthermore, we need a gas, a liquid or a solid that serves as the gain medium and creates identical photons. Another mirror with a reflectivity of about 98% must be installed at the other end of the gain medium. Another part we need is an energy source in order to use photons to raise electrons from a lower energy level to a higher one, a process called optical pumping.
So, pinatawag nga optical pumping, another energy source. So, ito nga ginagamit, isang flash tube, gina. Okay, so optical pumping, ang siyang nag-pump ng energy to get these electrons inside this chamber excited.
Now, let's have a look at the inside of the gain medium. The atom and the electron are on the ground state. Now, optical pumping, that is emitting energy in the form of photons, is used to raise the electron into a higher energy level. In this case, its energy level is E2. After a short period of time, the electron jumps into energy level E1 without emission of a photon. Consequently, the process of optical pumping cannot cause stimulated emission because there are two different amounts of energy present. The electron will maintain its energy level E1 for some time. Then, the atom will spontaneously emit a photon in a random direction as it relaxes to a lower electronic state. This photon may interact with an excited atom that hasn't emitted a photon yet. So, the photon hits the excited atom and causes a stimulated emission because the photon has the exact amount of energy to do that. Only photons emitted in a direction perpendicular to the mirrors will be reflected. The reflected photons initiate a chain reaction to produce more and more photons of the same kind. Furthermore, only photons with the same amount of energy and the same momentum will be part of the chain reaction. That's the reason why laser beams are strongly coherent and monochromatic. A very important aspect is the fact that many atoms must be in an excited state. For a laser to work, more atoms must be in an excited state than in lower energy states. This is called population inversion. The semi-transparent mirror allows some of the laser energy to be emitted while bouncing most of it back through the laser. There are many other cool things about lasers, but for now, that's all.
Okay, so that is the mechanism of lasers, how they work. Questions? Questions so far? So just tally your score. Be sure to record this one because I'll be requiring this tally of points again sa inyong group. Number questions? None. Sige ah. So I'll be stopping the recording right now. So the